Alright, so we will solve a problem on force vectors today. Essentially, we're going to consider a force vector. We will look at two directions, and we would like to find the magnitude of the force vector along these two directions. So here is the problem. So I have two directions. Let's call this as u, and I have the v direction here. And I have a force vector that is given to me, and this force vector, let's call it as F, has a magnitude of 150 newtons. Now some angle information is also given to us. One of the information that is given to us is this angle here is 30 degrees. Then I have one more angle given to me, the angle between u and a vertical line which I'm going to extend right here. So this entire angle is given to me as 105 degrees. And what do I need to find in this problem? I need to find out f suffix u, and I need to find f suffix v. Right, so I need to find these two components. Alright, so the first thing I typically do is I see, based on the angle information, can I find the remaining angles? And of course we can easily do this. You see that if I add this angle with the 105, that should be 180 degrees, which means this has to be 75 degrees. And then I know that if I add the 30 degrees, the 75 degrees, and the angle in here, that should give me another 180 degrees, and 75 and 30 is 105, so 180 minus 105 is a 75 degree angle right there. Alright, so we have all our angle information. Now all I have to do is take this angle information and then draw the force in terms of its components along the v and the u directions, and perhaps use some kind of trigonometric identities or trigonometric rules in order to find the components along the u and the v directions. So let's take a look at that. So I'm going to redraw the entire situation right here. So I have the v and the u direction. So this is u and this is v. I have the force vector here. Right, now the first step I take in finding the components is from the head of the force vector F, I draw a line that is parallel to the v direction. Right, so I'll draw it as a dotted line right here, and this is intersecting the u axis at a particular point, which means that if I start from the tail of the force vector F and if I go all the way onto that point of intersection, this is going to give me f suffix u. And of course I'm going to write it as a vector because this is indeed a vector component of the resultant vector f. Now I do the same thing. From the head of the force F, I draw a line parallel to the u direction, right, as it goes here. And as you can guess, this is going to intersect the v direction at a particular point. Starting from the tail of F all the way to this point of intersection, if I draw the force vector, then that's going to give me f suffix v. And of course this is the force vector f right there. I have some angle information. This angle here I know was 30 degrees. If this angle is 30 degrees, then I can say that okay, this angle here is going to be the alternate angle to this one, and alternate angles are equal if I consider these lines here. These lines are parallel to each other, the u and the line parallel to it, which means that this angle is also 30 degrees. I already know that this angle here was 75 degrees, and I can find the remaining angle, the third angle of the triangle right there. And one more thing I also know is since this is a parallelogram, then opposite sides are the same, which means that this is also f suffix u. Alright, so now I have all this information. How do I find the magnitude of the components? And for that we need to take a look at the magnitudes only, and here is the situation. So let me take a new page. So now I'm going to redraw the situation we had earlier on with all the angles found out. So here is the case. I had the v direction and the u direction, then I had the force vector F. I had drawn lines parallel to the u and the v direction, and I have found out that okay, if this is the v direction and this is the u direction, now I have this as the force vector F. Now I'm going to draw them as magnitudes only. This is the force vector F v, and this is the force vector F u, where F suffix u and F suffix v are components of the force F. I have some angles here. This angle we know is 75 degrees. This angle here is 30 degrees, and obviously this is the third angle of the triangle. 75 and 30 here is 105. 180 minus 105 is 75 degrees once more. Right. So I'm going to take a look at only this particular triangle here. I'm going to shade it in a different color. So take a look at this triangle here and redraw just that particular triangle. I'll draw it in a slightly bigger sense here. So I have this here, then I have that, and then I have the vector F itself. This is F suffix v, this was F suffix u, and this was F, and F was equal to 150 newtons in magnitude, as you might recall from the original problem statement. You see that this angle we know is 75, we know that this is also 75, and this is 30 degrees. And the easiest way to find out what the magnitudes of F suffix u and F suffix v are is by using the law of sines. Alright, so let's use the law of sines or the sine rule. There are different ways of calling this, but this is really crucial that one knows to use the sine rule and the cosine rule. These are perhaps the most useful of the trigonometric identities at this point in time. So we will revisit the sine rule, and it is also useful to know the cosine rule. And here we are going to make use of the sine rule. For this particular triangle, and the idea is I take a side, let's say that force F side, I divide it by the sine of the angle opposite to that, which is 75 degrees. So this is sine 75. This has to be equal to the ratio of, let me take any one of the other sides, which is F suffix v, let's say, divided by the sine of the angle opposite to F suffix v, which is sine 30. And in turn this has to be equal to the remaining side, which is F suffix u, divided by the sine of the angle opposite to that, and that is sine of 75. And some of the more discerning of you would have already found out that okay, we are dealing with an isosceles triangle here, which means that if I look at the angles, 75 and 75 are the same, which means I have a large amount of suspicion that the magnitude of F suffix u has to be the same as the force vector F. And this is indeed true, as you can see from these ratios that we have written here. Right, so continuing to the end of the problem. I have the following ratios. F I know is 150 newtons, so this is going to be 150 by sine of 75 degrees. This is going to be equal to F suffix v, which is unknown, which we can find out now. It's divided by sine of 30, and this is equal to F suffix u by sine of 75 once more. So I can find out F suffix v by considering these two and cross multiplying. I can find out that F suffix v is essentially 150 times sine 30 divided by sine 75, and once you go through the calculations, this will give you a value that is approximately 77.6 newtons. So this implies that F suffix v is 77.6 newtons. then I could either use this ratio FV by sine 30 is equal to FU by sine 75, or I can use the fact that this has to be the same as that as well, and then I can find out F suffix U as follows. So this is essentially 150. I make use of the force value that is given to me, cross multiply. This is going to be sine 75 by sine 75, and common sense tells us that these two are the same, and so this tells me that F suffix U is 150 newtons. Now notice that we have the magnitudes only specified here. We are not interested in the directions because the problem did not ask us for the directions. Common ways in which this problem can be slightly made harder is the following. So perhaps we could imagine the situation given as follows. So let's say that I have the same U and the V directions. Let's say that I have, this is the V and then this is the U. So this is U and this is V, and instead of the force being given the way it was in the problem, this force could be drawn in the following manner. So this could be the force F. The way to break it into the components is in a same way as we have solved the previous problem, except that we have to be careful as to how the components are drawn on the U and the V directions, or along the U and the V directions, and here goes. So once again I redraw my U and V directions. This is the U, this is the V direction. I have the force vector which is given to me originally. This is the force vector F. I draw a line from where now? This has to be from the tail here, parallel to the V direction. I draw a line from the tail parallel to the U direction. They are going to intersect at these two particular points, and when I'm drawing the components now, you see that the component along V has changed in direction, and this has to be FV. And similarly, if this is the component along FU, this has to be F suffix U, F suffix V, and this is the force vector F. Thank you.